For as long as we've looked up at the stars, we've asked the exact same question: is anyone else out there? In 1961, astronomer Frank Drake tried to turn that philosophical question into a mathematical one. He developed the Drake equation, a probabilistic roadmap designed to estimate the number of communicative civilizations in the Milky Way, factoring in things like star formation rates and the fraction of planets that might support life. Trying to solve those specific variables essentially split the scientific community down the middle, creating two distinct research camps with very different ideas on how to track down our cosmic neighbors. Yet, after 60 years of scanning the skies, both of these groups are running into the exact same wall. The universe is incredibly noisy, and deep space data is thick with ambiguity. On one side, we have astrobiologists hunting for biosignatures. They are looking for the chemical byproducts of living organisms, like specific combinations of atmospheric gases on distant exoplanets. On the other side is the search for extraterrestrial intelligence, or SETI. They focus on technosignatures, listening for the artificial byproducts of advanced civilizations, like narrowband radio transmitters. One group searches for microbes, the other searches for radio transmitters. But both methods are stalled by a frustrating reality. The cosmos is exceptionally good at creating mirages that look exactly like life. The historical gold standard for a SETI detection happened in 1977. Ohio State University's Big Ear Telescope picked up an incredibly strong anomalous radio burst that famously became known as the wow signal. What made this signal so compelling was its frequency. It came in exactly at 1420 megahertz. This is known as the hydrogen line, a quiet frequency range that astronomers have long theorized an alien species might use to broadcast a beacon. Because it was such a sharp, narrow-band burst sitting perfectly at that frequency, researchers assumed for decades that it had to be an artificial signature. It simply didn't match the profile of random space noise. That interpretation held up until a recent effort called the Arecibo WOW project began reanalyzing decades of previously unpublished archival data. Using modern techniques, the team recalculated the signal's intensity. They discovered its peak flux density exceeded 250 Janskis, a measure of radio emission strength. That makes the blast over 4 times stronger than anyone previously realized. That extreme intensity points to a newly proposed astrophysical mechanism, a magnetar firing a high-energy flare into a massive interstellar hydrogen cloud. This radiation causes a natural maser-like flare, emitting the exact narrowband radio waves expected from an artificial transmitter. It turns out the most famous candidate for alien technology in human history is highly likely to be the result of natural cosmic weather. The exact same problem of mistaken identity plagues astrobiologists today. Recently, the James Webb Space Telescope spent 290 hours observing TRAPPIST-1b, an Earth-sized exoplanet 40 light-years away. Early models suggested this planet was heavily irradiated by its host star, leaving it as a dark, geologically dead rock completely stripped of any atmosphere. But new thermal infrared measurements from JWST picked up an anomaly. The data showed a lack of surface weathering and a specific heat signature that strongly suggests the planet actually has a hazy atmosphere made of carbon dioxide. There is just one catch. That exact same heat signature can also be produced by intense geological activity. Massive, widespread volcanism could explain the lack of weathering and output the exact thermal profile the telescope detected. As astronomer Jason Wright points out, whether you are scanning for atmospheric gases or listening for radio bursts, identifying life requires navigating a maze of abiotic mimicry. The universe easily produces dead things that look surprisingly alive. Moving past these cosmic illusions requires the scientific community to abandon their siloed camps. Instead of relying on a single data point, researchers are adopting a rigorous mixed strategy that demands a wide constellation of ambiguous signals occurring together to prove life exists. To gather that massive amount of cross-disciplinary evidence, NASA is currently preparing to launch the Nancy Grace Roman Space Telescope. Roman will feature a 300-megapixel wide-field instrument, allowing it to capture vast surveys of the sky at a resolution matching the Hubble telescope, but covering 200 times more area. Crucially, it will also carry the coronagraph instrument, or CGI. Its job is to isolate the incredibly faint light reflecting off an exoplanet. The instrument uses a complex sequence of masks and prisms to physically block the overwhelming stellar glare. Behind those masks, thousands of tiny actuators push and pull on deformable mirrors, dynamically adjusting their shape to correct for optical distortions. This effectively strips away the stellar glare, leaving behind the faint, isolated image of a hidden planet. Confirming we are not alone won't happen in a single flash of discovery. It will be the result of unifying our scientific disciplines and utilizing advanced optical engineering to finally separate the true signal from the endless cosmic noise.